If yes, then please write in the chat box. Athar, Mithilesh, Parth, Prachi. Okay, so maybe we can start the class.
Yes, just a minute. Yes, good evening, everyone. So today we'll start with fractions. I hope you can see my screen. Yes. Okay, so let's start. So first of all, what is a fraction? It is actually a part of a whole, right? So let's say you have a pie or a circle, okay? And it's been divided into 4 equal parts. Okay? And if I asked you how do you refer to this part, okay? The shaded part, how do we express it? Okay? So for this, we use fractions. Okay? It's a part of this whole circle. So can anyone answer? How do we represent this part? Respond in the chat box. We have a third part. Prachi. Yes. Anyone? Swastik. Okay. So it's like we have 4 parts, okay? And we have shaded one part. So this can be expressed as a fraction. And in a fraction, we have 2 numbers. One on the top, which is 1 in this case. This is known as numerator. And the other one at the bottom is known as denominator. So basically, we have shaded 1 out of 4. Okay? So it's like 1 upon 4, or it's also known as a quarter. Right? So fraction is a part of a whole. Right? Similarly, here you can see there is a circle, and it is divided into 8 equal parts, and 3 of these parts are shaded. So now we are referring to these 3. So it's like 3 out of 8. Okay. So 3 is at the top, 8 is at the bottom. So 3 is your numerator, 8 is the denominator. Okay. Fine. Now, yeah, so here you can see different value of fractions. So let's ignore this for now. Yeah, can you guys answer? What does the first shaded region represent in terms of fractions? Yes, anyone? Yes, was the correct. It's half. Okay. So Here you can see a bar that has been divided into two equal parts, and we have shaded 1. So it's basically 1 out of 2, which is 1 upon 2, or we also call it as half. What about the second one? Parth? Parth, Neha? Yes. What's the fraction which this region represent? Okay, so that's the good. So here we can see that we're talking about this one part, the second one with this purple color here, this one. Here, the second one. So it's 1/3, right? Because here the bar is divided into 3 equal parts, and one of those 3 is shaded. So it's 1 out of 3, or we call it 1/3. Similarly, in the next one, okay, third bar, again we see 1 part shaded, and which fraction does it represent? Yes, Parth, good. So it's 1 out of 4, or it's a quarter, or you can call it 1/4. Finally, the last one. Yeah, so Astik, it's pretty straightforward. You can see here the bar is divided into 5 parts. 1 is shaded, so it's 1/5. All of these parts are equal. Okay, it's important. These are equal parts. So 1/5. Fine. I hope this is clear. Any questions? So this is the basic definition of a fraction. Anyone? No. Okay. Fine. Now next is writing fractions. So how do we write fractions? How do we pronounce a fraction? So let's say you have this fraction. There is a circle. So can you write the fraction? Yes, guys, please respond. Yes, Swastik. So yeah. So here you have 7 equal parts, and we have shaded 4. So this can be expressed as 4 upon 7. Okay. And how do we pronounce it? We say it's 4 sevenths. Okay, 4 from the numerator, this sevenths from the denominator. Okay, sevenths. Okay, so TH in the end. Yes, Parth. Devika, no. So Devika, here we have 7 equal parts. Okay, and 4 of them have been shaded. Right? So the shaded part can be expressed as a fraction in this form: 4 out of 7. Okay, so this can be read as 4 sevenths. Okay, similarly, let's say if you have something like this, 3/8, you can read it as 3/8. Okay, I hope this is clear. Any questions? Yes, guys. Okay. Yes, Parth. Okay. Fine. Now let's try some questions. So answer this. This is the first one. Let's call it part A. Yes, Devika. Mitlesh. First one. Swastik and Parth have answered. Others, Devika, Mitlesh. Yes. Yes, Swastik. So 1, 2. Devika. Okay. 1, 2. So 1, 2, 3, 4, 5, 6, 7. Out of, you can see that 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 parts. Okay. This triangle has been divided into 16 equal parts, and 7 of them have been shaded. So it's 7 upon 16, or this can be read as 7/16. Okay, fine, Mitlesh, Swastik, Devika, fine. Parth has answered the second part as well. Yes, others? Yes, good, Swastik. So you can see this bar has been divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. Okay. And 8 parts have been shaded. So this is like 8 out of 12. Okay. 8 upon 12 or 8 over 12. And you can read it as 8 twelfths. Okay. Yes. Any questions? Okay, fine. So now let's move to the next question. Yes. Answer this, guys. You can see a circle. So part A, part, what fraction is in blue? That's the question. The answer is not correct. Devika, is it 8 over 1? Part, what are you doing? Mitlesh, no. Yeah, Devika. So, Swastik, correct, yeah. So, you can see that the circle has been divided into 8 equal parts, and one of them is shaded blue. Okay, so it's 1 out of 8. Okay, or 1/8. Next one, what fraction is in orange? So, yeah, you can see two parts are shaded in orange. So 2 out of 8 or 2/8. Fine. Now let's move to the worksheet quickly. Yes, so try this. Let me zoom in. Okay, first one. Yeah. So numerator is 1, denominator is 4. Second one, replace not one third. Okay, Yashika, 2 out of 9. Third one, yes, Mitlesh. Now it's correct. Parth, fine. Swastik, okay. Next one, 1, 2, 3, 4, 5. Yeah, 5 upon 14. Okay, good. Or 5 14ths. Next one, 3. Yeah, yes, Parth, correct. Mitlesh, correct. 3 upon 8. Yeah. Next one, good. Fifth, fifth one. 1, 2, 3, 4, 5, 6. Yeah, it's same. 3 over 8. Yeah, sixth one. Yes, Yashika, Swastik, Parth, fine. Next. Okay, here you need to be bit careful, guys. Okay, this one is not that straightforward. Look at the diagram carefully. Now see, here you can see that the parts are not. Yes, you have to be careful for this. So, wait. 3 over 6. Now someone is saying 3 over 9. Guys think seventh. I'm talking about seventh part. What's your answer? Okay, eighth one is easy. 1, 2. Okay, eighth one again. You have to be bit careful. First, seventh one. Let's finish seventh one. So see, these parts are not equal. Look at this and see the other parts as well. So first, we need to actually divide this further. Okay, to be right. So in seventh one, just to ensure that parts are equal, we have to divide the circle further. Okay, now you can see that these are equal. Okay. So what's the answer here? Seventh one. Most of you were wrong. Yeah, Yashika. It's 3 over 8. It's not 3 over 6 or 3 over 9. Parth, you are in a hurry. Okay, think. Is this clear, guys? Seventh one. Swastik, Mitlesh. Okay. Devika. Okay, eighth one is again not that straightforward. Again, guys, you are in a hurry. Swastik, Parth, you are not thinking. Look at the diagram carefully. Yes, Devika, Yashika. Good. So, yeah. So, if you look at this carefully, right, we need to divide this further. So now we can see like this, or you can do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, so it's 3 out of 12. Okay, Parth, Swastik. Yes, is this clear, Parth? Yeah. Okay, fine, good. Now, next one again, think. Question number 9. Yes, yes, Devika, Swastik. So here again, you can see that it's 1 out of 4. Yeah. Last one, 10. So we need to divide the circle. Okay, Parth. Yes, Devika. Fine. So here it's again 1 over 8. Okay. So in the next one, we need to color. Now you guys can't respond in chat. So I will shade the fraction. Okay. So first one, you can just tell me how many parts do I have to shade. So in the first one, I need to shade only one part. Okay. You can color any part. Yeah, part. Right. You can color this or this. Doesn't matter. In the second one, we need to color 3. Okay. 3 out of 8. So pick any 3. You can pick 2 of these, 1 of this. Okay. Third one, we have to color 3. Fourth one, 1. I'm doing it a bit quickly. Let me know if you have any questions. You can interrupt me. So 1 here, 1, 2, 3, 4. Here, pick any 3. Yes, this one, yeah. Answer this one, guys. Just tell me how many squares do I have to shade here. Question number 8. Swastik, look at the diagram carefully. Don't jump in to type the answer. So Yashika is saying 2. Okay, others? Devika 2. Yes, so there are 12 squares here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. Now we need to represent this. 1, yeah, Swastik. So there are 12. So do we have to shade only 1 to represent 1/6? No, we need to shade 2 actually. Okay. So 2 out of 12 is actually same as 1 out of 6. We'll come to that later. But I think you can easily figure this out. Swastik, is this clear? So 2 out of 12 is actually same as 1 out of 6. These are equivalent fractions. Fine. Okay. So I think it's better if we first discuss equivalent fractions, then we can come back to it. Okay, so let's move to different types of fractions. Okay, so first is proper fractions. So a proper fraction is a fraction in which the numerator is less than the denominator. Okay. So far we have actually discussed proper fractions only. So any fraction in which the numerator is less than the denominator is a proper fraction. Okay, fine. Next is improper fractions. So just the opposite of proper fraction. So in an improper fraction, numerator is actually greater than the denominator. For example, 7 over 3, okay, or 6 over 5. These are improper fractions because numerator is greater than the denominator. Okay. Next is mixed numbers. So mixed numbers, they are made up of a whole number and a proper fraction. Okay, so let's say if I write 1 and 1.5, 1 and half. So here you have a whole number and a fraction. Okay, so this is a mixed number. So let's do a simple exercise. Look at these fractions, guys, and answer. Proper fractions out of these three. Yeah, Devika, correct. So there's only one proper fraction here, right? 1 over 3. The first two, we can see that the numerator is greater than the denominator. Yeah. Second one, improper fraction. Yes, so 8 over 5. Fine. Yashika, Devika, Swastik, okay. And of course, the mixed number is this. Okay. Fine. So this was pretty straightforward. Okay. Now let's move to equivalent fractions. Okay. Now this is important. So equivalent fractions are different fractions that have the same value. So their numerators and denominators may be different, but they have the same value. They represent the same part. Okay. So you can see a simple example here. You can see a circle. Okay. Now, in the first case, you have only one shaded part. Okay. The circle has been divided into two, right? And one of this is shaded. So we say that this is half. Okay. 1 out of 2. Now, if you look at the second one, here the circle has been divided into 4 parts. And we have shaded two out of those 4. So this is basically 2 out of 4. In the third one, circle has been divided into 6 equal parts. And we have shaded 3 out of those 6. So it's basically 3 out of 6. And the last one you can see 8 equal parts. 4 have been shaded. So we have 4 over 8. But if you look at these 4 circles, right, we see that they actually represent the same part. Okay? This and this and this and this. Eventually, we have the same part shaded in all four circles. So what does this mean? This means that all these four fractions, although they look different, but they are actually the same. So we call them equivalent fractions. Okay, they represent the same number. I hope this is clear. Any questions here? Anyone? No. Okay. Fine. So let's take another example. You can see that here we have two bars. Okay. In the first case, we have divided the bar into uh, three equal parts. Okay, two parts are shaded. So the fraction is 2 out of 3, okay, or 2 over 3. In the second case, the bar is divided into 6 equal parts and 4 parts have been shaded. But if you look at this carefully, we have shaded the same part. Okay, so although it's 4 out of 6, but it is actually same as 2 out of 3. Okay, so these two are also equivalent fractions. Yeah. So next is, how do we find equivalent fractions? So let's say you have any number, any fraction. So let's say you have half. We want to find its equivalent fraction. First of all, there can be infinite equivalent fractions of a particular fraction. Okay? So to find a equivalent fraction of the given fraction, what do? We simply multiply both the numerator and denominator by the same number. Okay? We can multiply or divide. So let's say you have half. So you can multiply both numerator and denominator by 2. So we get 2 over 4. Or you can multiply and divide by 3. So 3 over 6. And so on. Okay, this can go on. You can pick any number. You just need to ensure that you're actually multiplying the numerator and denominator by the same number. Okay? It has to be the same. We can multiply or we can divide. Similarly, let's say if you want to divide, let's say you have 8 over 16. Okay? So we can divide the numerator by 4 and denominator by 4. So 2 over 4 and so on. Any questions here? Anyone? Okay, fine. Okay, next is like fraction. So what are like fractions? Fractions that have the same denominators. Okay. So for example, you can see here 2 over 7, 4 over 7, 3 over 7, 5 over 7, 6 over 7. All of these have the same denominator 7. So these are like fractions. Okay. Then we have unlike fractions. Fractions that do not have the same denominator. So here you can see all these fractions have different denominators. Okay, so these are unlike fractions. So I hope this is clear. Any questions? No. Okay. So now let's go back to the worksheet and finish this part. Okay, so let's try this. Yeah, 1/3. We need to shade. Yashika, so you are saying how many parts should I shade? That's the question, Yashika. Yashika and Parth. Two, yeah, correct. Okay. So you can see we need to express 1/3, but here the given figure has been divided into 6 equal parts. So we need to use the concept of equivalent fractions. Okay. So 1/3 is same as 2/6. Okay. So we need to shade 2. Yes, correct. Now next one, question number 10. Guys, try this. Others, Mitlesh, Swastik, Devika. Question number 10. Devika, 3 out of 9. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So here we have 9 parts. Okay. So that means we need to shade 3 because 1/3 is same as 3 nines. Okay, guys, good. So pick any 3 parts. Mitlesh. Okay, part. Mitlesh, can you answer this one? Mitlesh, Swastik. 11th one. Yes, Swastik. Okay, fine. So we need to represent half, but here the square has been divided into 4 equal parts. So we need to find an equivalent fraction, which is 2 out of 4. So shade 2. Okay. Now, okay, so this is pretty straightforward. Numerator is 5, denominator is 9. So the fraction would be 5 over 9. Okay, second one, denominator is 6, numerator is 1. What would be the fraction, guys? Yes, quickly respond. Yeah, 1 over 6. Third one, 7 over 12. Correct. Last one, okay, Parth. Niklesh, are you there? You're not responding. Last one, yeah, 2 out of 5. Okay, guys, good. Now, okay, so in this question, we have to write fractions. So read the statement and try to write a fraction to express this. Okay, Ashika, fine. Others? Parth? Yeah. So 5 hours of a day. So we know that in a day there are 24 hours. So we need to represent 5 out of 24. Okay. Okay, second one, 7 minutes of an hour. Yes. 5, 7 over 60. Third one, 5 months in a year. 5, yeah, 5 over 12. Okay, fourth one, 70 days in a leap year. Okay, Yashika. Others, Devika, Swastik. Yes, so 70 over 366. A leap year has 366 days. Don't write 365. Okay, Devika. Next one, 21 red pens out of 50 pens. Yes, so 21 out of 50. 12 grams out of 35. 12 out of 35. Okay, guys. Next one, 5 out of 80. Yeah. Then 3 out of 10. 7 bananas out of 1 dozen bananas. Yeah, a dozen is 12. Then we have 9 over 52. Okay, let's try this one as well. So circle the like fractions here. So identify like fractions. Look at these. 2/3. Devika. So what are like fractions? Just now we discussed fractions that have the same denominator. So okay, Yashika, fine. You can see that this 1/7, 5/7, 4/7, and 3/7. These are like fractions. They have the same denominator. Okay. I hope this is clear. Now, okay, let's move to addition and subtraction of fractions. So, first is how do we add and subtract like fractions? Okay. So, what do we mean by like fractions? Like fractions are fractions that have the same denominators. Okay. So, let's say you have two like fractions. 2 over 3. Let's take something else. 2 over 5 and 1 over 5. So these are like fractions. They have the same denominator. So to add such fractions, we just need to add the numerators. Okay? It's pretty straightforward. Just add the numerators. Yeah. 3 over 5. Okay? Similarly, if you want to subtract, same process. Just subtract the numerators. Okay. Yes. Now you can easily solve these problems. Yes, guys. 3 out of 9 plus 4 out of 9 is equal to, the path is answered. Others, yes, 7 out of 9. And the second one is 5 out of 7 minus 2 out of 7 is equal to, yeah, 5 minus 2 is 3 out of 7. So, okay, let's now come to the worksheet. Yes, so answer this question. First one. Yeah, so 1 plus 1 over 3, 2 over 3. Second one. Yeah, so 2 plus 1 over 5, 3 over 5, then 3 plus 4 over 8, that is 7 over 8. Yes, others? Swastik? Then 7 plus 1, yeah, 8 over 9. Then t plus 2. Okay, Swastik. Yashika, 5 over 8. Okay. Now subtraction. Yes. These are pretty easy. 5 over 9. Let's just quickly finish this. 2 over 7. Okay. Then, yeah, 9, 6 over 11. Yes, 3 over 13. Yes, then 11 over 15. Okay, so now let's discuss addition and subtraction of unlike fractions. Okay. So how do we add unlike fractions? Anyone? Let's say we have this 2 over 5 and 1 over 3. Okay. So here you can see that the denominators are different. So you can't simply add, the numerators. So what do we do in such cases? Yashika has answered. So to solve such problems, we need to use the concept of equivalent fractions. Okay. We need to make the denominators same, right? Or basically we need to convert these fractions into like fractions. So what we can do, yeah, in other words, we need to take LCM. Yeah. Yes, Swastik, but we'll come to that later. For now, yeah. So what we'll do, you can see here we have 5, here we have 3. Okay. So if we think carefully, then the common denominator can be the least common multiple, okay, or LCM, which is nothing but 15 in this case. So somehow we need to get 15 here. So what we'll do, we'll multiply both the numerator and denominator of the first fraction by 3, okay, and to get 15 in the second fraction, we need to multiply and divide both the numerator and denominator. Sorry, we need to multiply both the numerator and denominator by 5. Okay. Now you can see that 2 over 5 becomes 6 over 15 and 1 over 3 becomes 5 over 15. Okay. Now these are two like fractions, so we can simply add the numerators. So what have we done? Essentially, we have taken the LCM of the denominators and found the common denominator. Right? Is this clear? Any questions? Okay, so now try this. So here you need to subtract. Try this. I'll be just back in a minute. Yes, guys, I'm back. So, Swastik, Yashika are saying 11 over 18. Devika, 57 over 54. Yeah, the common denominator can be 54, but the numerator, Devika. So see here again we have 5 over 6 and 2 over 9. So these are unlike fractions. So first we need to make the denominator same. Now we have discussed how to find LCM. So you can see that their least common multiple is 2 times 3 times 3, which is equal to 18, right? So we'll try to make the denominators of both the fractions 18. Yes, Parth, listen. So 5. So here we need to get 18. So that means we need to multiply both the numerator and denominator of the first fraction by 3. In the second case, again, we need to make 18. So that means 9 has to be multiplied by 2. So we'll also multiply the numerator by 2. Okay. So now we have 15 over 18 minus 4 over 18, which is equal to 11 over. Devika, you're getting 9 over 54. That's not correct. I think you made a mistake somewhere. See, okay, so Devika has done something different. Let's discuss that as well. So I believe what Devika has done is, so yes, Parth. Okay, what's the question? How you can multiply by 3 and 2? So see, Parth, we are using the concept of equivalent fractions. Okay, so these are two unlike fractions. So first, what I did, I found the LCM of the denominators. Okay, now the LCM is 18, right? That means this is the least common multiple of both 6 and 9. So if I can ensure that denominator of each of these fractions, okay, is 18, then it's quite easy for me to subtract, right? Because we can easily subtract like fractions. We just have to subtract the numerators, right? So if I can somehow ensure that the denominator of the first fraction becomes 18, then my job is easy, right? So what I'm doing, I'm using the concept of equivalent fractions. So I need to get to 18 from 6. How will I do that? I need to multiply this by 3. And when I do that, okay, I need to ensure that I'm not changing the fraction. So at the same time, I'm going to multiply the numerator by 3 as well. Okay, so 5 over 6 becomes 15 over 18. Parth, did you understand? Okay, yeah. Same thing we did with 2 over 9. Okay. Again, I need to ensure that somehow I get 18 here. Okay. So how will I get 18 when I multiply 9 by 2? But if I do that, I need to ensure that the fraction does not change. So at the same time, I multiply the numerator by 2. So this is a powerful thing with fractions. Okay. You can use the concept of equivalent fractions without actually changing the fraction. Okay. Now what Devika did, let's discuss that as well. Devika, 9 out of 54 is not correct. Let's check your approach as well. So what Devika did, okay, we had the same fractions, but she thought that let's use 54 as the common denominator, which is also fine. Okay, no issues. Although we don't prefer it, but it's okay. As long as the denominators are same, we don't care that much. Okay. So what she did, she thought that 54 is a common multiple of 6 and 9. Okay. So let's change that to okay, so let's change the denominators to 54. So if I do that, I need to multiply the numerator and denominator of the first fraction by 9. Okay. And the second fraction, we need to multiply the numerator and denominator by 6. Okay. This is perfectly fine. So this becomes 45 over 54 minus 12 over 54. So Devika, you made a mistake somewhere here. So it's 54, but 45 minus 12 is 33. Okay. Now you might think that these two are different, but they are not. If you look carefully, these are equivalent fractions. Okay. 33 over 54 is same as 11 over 80. Is this clear, guys? So there can be different approaches here, but the idea is same. We need to ensure that the denominators become same. Okay. Once the denominators are same, we have like fractions. We can easily add and subtract the numerators. Yes, Devika, is this clear? Others? Any questions? Devika, are you there? Okay, fine. So time is up, right? So let's end the session here. We'll continue this in the next one. Okay, thank you.
Thank you so much, Kapil sir. It was very interesting session. Yeah. And the way of teaching is also very nice, and hopefully it's easy to understand for everyone. So guys, our next class is on 3rd Feb, Saturday. So I will share the worksheet for next class tomorrow. Okay? So see you on 3rd Feb. Yeah. Hey, did you, by any chance, did you mention this about this class to your friends? Some of them did, but what about the rest one? Yes, Swastik, yeah, I know, like, your friend joined today. But please, Parth, Mithlesh, Devika, Yashika, you also, please also inform your friends, and if you have any cousins who can benefit with these classes, please do tell them, okay? Thank you so much. Okay, good night. Thank you so much, Parth.